In this video, we're going to talk about percent error. Percent error is a measure of how inaccurate a measurement is. An example of this would be something like, and I know how strange this sounds, if you made an estimate of something, number of people on the bus, how many jelly beans in a jar, how far away something was, and then you were able to find the actual answer, the factual answer, not the estimate, you could compare how far off your estimate was from the actual answer. All right, so the percent of error equation, it equals the measured or estimated value minus the actual value divided by the actual value. And I think that will make a lot more sense once I do this example. But there's a note here, as you can see, in bold and italicized. And what it says is, note that the numerator is inside an absolute value symbol. The numerator is always positive in a percent error equation. For those of you who don't remember, these vertical bars right here, those are what I'm talking about when I'm talking about an absolute value symbol. All right. Why does it have to be a positive number? Well, percent error is always a positive. We're just talking about how far someone was off. It's never negative. It's always going to be positive. You are 20% off or 10% off or whatever have you. All right, let's take a look at the problem that we have. Bob estimated that there were 36 people on a bus. If the actual number of people on the bus was 45, what was the percent error? All right, I'm going to slide this up just a little bit, and let's see what we can find out. So our percent error, that's going to equal our estimated value, which was 36 people on the bus, minus the actual value, which was 45 people on the bus, divided by the actual number of people, the actual value, which was 45. And remember, this is in, absolute value symbols. All right, so 36 minus 45 is negative 9. And by the way, you could actually just subtract 36 from 45, but we're going to do it this way, because we know we're going to have to end up with a positive. So there's my absolute value symbol. There's my negative 9. I'm going to put that over 45. And I just want to make that a little bolder so it's clear. That's an absolute value symbol. So now what I've got is the absolute value of negative 9 divided by 45. That will, of course, equal 9, because the absolute value is always positive over 45. And if you don't remember, an absolute value is a number's distance from 0. And no matter if it's positive or negative, the absolute value is going to be positive, because distance is positive. All right. So now I need to convert 9 over 45 into a decimal and then into a percent. And using a calculator, you would see that 9 divided by 45 would equal 0.2. And 0.2, of course, equals, it's not approximate, it's equals, moving my decimal point once, twice, 20%. What does that mean? That means that Bob's percent error equaled 20%.